Hi, my name is Moriarty. I am very smart and can answer all your questions.
Thanks, Jim. This is the final project report for Team Moriarty on our question and answering program. So the first thing we're going to discuss is our question generating module. So the first thing we want to do is do the easiest thing possible. Just make a couple of hard questions that can apply to any article, such as what are the important topics covered in the document, or can you summarize the text? This is basically free. It costs us almost nothing to implement and makes a couple of good hard questions for other teams to deal with. Next, for the easy and medium questions, we need to format the text in some way that allows us to recognize the patterns. We used the NLTK tokenizer and the NLTK part-of-speech tagger for this. To make some easy questions, we wanted to find a pattern we can very easily convert into a yes-no question. So when we see something like Dempsey was born in Texas, we know that Dempsey is some sort of proper noun from the part-of-speech tagging, and we know that was is a word that lends itself to yes-no questions very easily, so we can just switch the was and the Dempsey around and we can get was Dempsey born in Texas, and we don't even need to know about the rest of the sentence born in Texas. We can just worry about the start of it and have a free easy question that way. Next, we added a chance to substitute in a bogus name like Batman or Sherlock Holmes or something. This is meant to deceive other teams that might use fuzzy string matching. So they may see a sentence in the text very similar to the question and answer yes, but in reality the answer is no. Next, we wanted to look at each sentence individually and see if there is a tag pattern that matches one of the rules that we predefined. For example, if you have Clint Dempsey, the top scorer for Barcelona, you can see proper noun, comma, noun phrase, comma. You can turn that around and make those two equivalent and say who is the top scorer for Barcelona. You don't need to break down top scorer for Barcelona any farther than NP. Next, we decided to try to confuse other answers by avoiding some question words. When is a question word that easily tips you off that you're looking for a date. So instead of a question like, when was Dempsey born, we decided to say, Dempsey was born on what date? It's perfectly correct English. It asks the exact same question. It's just a little bit harder to answer and a little bit easier for us to generate. To make some harder questions, sometimes we have to rely on multiple sentences. For example, Dempsey was born in Texas. He is the leading goal scorer. You have to have both of those sentences in order to answer the question, who is the leading goal scorer? And this will usually require some sort of co-reference resolution in order to realize that Dempsey and he are the same person. We can generate these questions using the references generated by the Core NLP co-reference module. To make some even harder questions, we can change words around into different forms. So if we have Dempsey was born in Texas, a good way to fool string matching type programs is to rephrase born into some other way. So we can say, what is the birthplace of Dempsey? This relies on the relationship between the words, not just the word itself. So in order to do that, we had to use the Stanford relation extractor. Transformations like born in to birthplace will be able to fool some of the fuzzy string matching approaches, hopefully. We also attempted some other techniques. We tried to use the Stanford relation extractor to create questions using antonyms and synonyms from WordNet. So if you had a question, or if you had a sentence, John is taller than Jane, that would turn into, is Jane shorter than John? But it didn't work. So moving on to the answering module. First thing in our answering module, we want to see if it's one of the questions that we made. That's pretty easy to spot if one of our bogus names like Batman or Sherlock Holmes came in. If we see that, we can just answer no straight away. Next, we want to look for question words at the start of the question, like does, who, when. That tells us exactly what sort of entity we're looking for and what answering technique we want to use. We can narrow it down a lot. If we don't find a question word right away, then we can look for one elsewhere in the sentence. Our first approach is fuzzy string matching with the fuzzy wuzzy Python module. So the fuzzy wuzzy module returns a similarity score for any two strings. So we compare the sentence, or each sentence in the article, to the question, and if one of them is a very similar match, we can return the sentence. Now, if the answer doesn't have a proper noun, though, if it's one of those two-sentence problems like we discussed in the question module, then we have to use Stanford coreference resolution to turn a pronoun, it's usually a pronoun, into a proper noun. And if we can't find an answer with that for yes-no questions, then we redirect them to the relation identification module. This looks for keywords like spouse in order to answer is Jane married to John. Hopefully it can solve some of the questions like the trickier ones we made. And as a last resort, if none of that works, then we're going to try just fuzzy string matching on every sentence in the article, and whatever sentence is closest to the question will return it, no matter how bad the score is. We also tried to get some quirky replies like, that's interesting, I should learn about that, because that's what some of the modern devices do in the real world if they can't answer one of your questions. That's about it for our project.